Welcome to aminacademy.com. In electrical engineering, let us discuss about insulation resistance of cable capacitors. What is insulation resistance of cable capacitor? The cable conductor is provided with a suitable thickness of insulating material in order to prevent leakage current. The path of leakage current is radial through the insulation. The opposition offered by insulation to leakage current is known as insulation resistance of the cable. For satisfactory operation, the insulation resistance of the cable should be very high. Consider a single core cable conductor of radius R1, this is a core, and internal sheath of radius R2, this radius R2 as shown in figure. Let L be the length of the cable and rho be the resistivity of the insulation. Here we are considering a cross section of the core wire, and here this is a core wire and insulation is like you have to take a distance from the center of the core to distance x, dx thickness ring you have to take. Consider a very small layer of insulation of thickness dx at radius x, the length through which the leakage current tends to flow in dx, and the area in x section offered to this flow is 2 pi xl. This area of this thickness is 2 pi xl. Insulation resistance of considered layer is for layer thickness dr equal rho into dx by 2 pi xl. Rho into length by area is dr. Insulation resistance of the whole cable is integrating this from 0 cable to R1 to R2. Then R equal integral R1 to R2, R1 to R2 rho into dx by 2 pi xl. Here take the constant of integration, that is here rho and 2 pi xl is a constant, into integral R to R1 1 over x dx. 1 over x dx is integral is rho by 2 pi L into 1 over x is ln ex. Then R equal to rho by 2 pi L log E R2 by R1. This is the radius resistance rho by 2 pi L log E R2 by R1. This shows that insulation resistance of a cable is inversely proportional to its length. Inversely proportional to its length. In other words, if the cable length increases, its insulation resistance decreases and vice versa. Now, let us do an example problem to understand this concept. The insulation resistance of a kilometer, 1 kilometer of a cable having conductor diameter is 2.5 centimeter and an insulation thickness is 2 centimeter is 400 mega ohm. What would be the insulation resistance if the thickness of the insulation were increased 4 centimeter? Here, first look at this. R equal insulation resistance is here insulation R equal to rho by 2 pi log E R2 by R1. Log E is considered as log 10 into 2.3, like here 2.3 rho over 2 pi L log base 10 R2 by R1 is the formula. Now here the given R1 cable radius equal diameter is 2.5 divided by 2 is 1.25 centimeter, and R2 is outer radius is 1.25 plus 2. The insulation thickness is 2. So core radius plus insulation thickness gives 3.25 centimeter. Then ratio R2 by R1 is equal 3.25 over 1.25, which gives 2.8 no unit. Then log of base 10 of 2.8. Log base 10 of 2.8 is approximately equal 0.4472. Then insulation resistance is given 400 mega ohm for the insulation thickness, and 400 mega ohm is in the resistance of the cable is equal to 400, because 400 mega ohm equal 400 mega ohm is 2.3 rho resistivity by 2 pi L, then 1 kilometer into this value 0.4472. Now let it be 1. Now next is that what would be the insulation resistance if the thickness of the insulation were increased by 4 centimeter. Then second case is R1 is 1.25 centimeter and R2 is increased 4, that is 1.25 plus 4 equal to 5.25 centimeter. Then here R2 by R1, the ratio is 5.25 over 1.25, which is equal 4.2. Then taking log base 10 of 4.2 equal 0.6232. Let it be 2. Now look at this here. Equation 1 says this 400 is equal this much and this is equal R. Therefore, we have to get it R2 here. Then R2 equal 2.3 rho over 2 pi L into 0.6232. Let it be equation 2. Now division of equation 2 by 1, which gives, that means look at here, this divided by this equal, that is R over 400 equal 0.6232 over 0.4472, which gives 1.394. From this, the relation R over 400 equal to 1.394. Therefore, R equal 1.394 into 400, which gives 557.6 mega ohm. That is, we got resistance of the, what would be the insulation resistance? Insulation resistance after increasing the thickness of the insulation gives R equal 557.6 mega ohm. We have done. Please subscribe our YouTube channel.